Hi everyone. Have you ever heard of hydrocarbons? If you have, good for you. If not, then don't worry, because today we'll be talking about testing saturation and unsaturation in hydrocarbons. If you happen to have some information about the topic, you may have an idea of where we're heading to. Hi, my name is Ferdinand Janmin Carlin. So today we'll be talking about 4 topics. First, what are alkanes? Second, what are alkenes? Third, why are alkanes generally unreactive? And fourth, which is the test for unsaturation itself, using bromine water. So first, let's talk about alkanes. Alkanes are a homologous series of hydrocarbons containing carbon-carbon single bond. Because they're homologous, they have similar chemical properties to each other, and they have trends in physical properties. Example of these physical properties involves that when their chain length of hydrogen and carbon increases, the boiling point increases as well. Alkanes share the same general formula of CnH2n plus 2. The number of hydrogen atoms in an alkane is twice the number of carbon atoms plus 2. An example will be methane, because methane has a formula of CH4. But how? Methane has 1 carbon atom, so the hydrogen atom will be twice of that plus 2, giving us a total of 4 hydrogen atoms. Alkane molecules can be represented by displayed formulae in which each atom, carbon and hydrogens, is shown as its symbol, which is C for carbon and H for hydrogen. And the covalent bonds, which are the bonds joining them, is labeled by a straight line. Alkanes are saturated hydrocarbons, meaning their carbon atoms are joined by single bonds only. This makes them relatively unreactive, but an exception to combustion or burning, as well as reaction with oxygen in the air. Here are examples of alkanes. We can see the pattern, whereas the number of carbon increases, the number of hydrogen also increases, following the formula shown before. We also see that each carbon and hydrogen atom are represented by their elements, either C or H, and are connected with only single bonds, which are shown by the straight lines. Next up, moving on to alkenes. Alkenes have similar properties like alkanes. The only difference is that it has double bonds instead of single bonds. The formula is also a bit different. Instead, the number of hydrogen atoms here is only twice the amount of carbon atoms. No additional 2 needed. Alkenes are unsaturated hydrocarbons because they contain a double bond. And these double bonds makes alkene more reactive than alkanes. Why? Before that, here are some examples of alkene. We can see that each alkene has a double bond on a pair of carbons. This is because of the double bond, since carbon atoms can only have 4 bonds because it has a valency of 4. Double bonds on the carbons makes it unsaturated hydrocarbons. We also see that alkenes of the same molecular formula can have different names. This is caused by the positioning of the double bonds. So, why are alkanes generally unreactive? First is because they are saturated. This is shown by the carbon atoms entirely joined with other carbon atoms and hydrogen atoms only with single bonds. There are no double bonds. So the bonds cannot break apart to form a reaction with other substances. However, regardless of being unreactive to other substances, they are reactive towards reaction of combustion, which is reacting with oxygen by burning or by air. So how do we identify alkanes from alkenes? One method is by doing the test for unsaturation, of course. How do we do it? To do this, we first need to prepare an alkane solution and an alkene solution, as well as some bromine water. We then add the bromine water to each solution, and once added, the solution will then be shaken. Notice the color changing on the illustration for alkenes. See it getting decolorized? The bromine will eventually react with the alkene solution, but not with the alkane solution. This causes bromine to be decolorized in alkene solution, but not in alkane. But how is this possible? When bromine is added into alkane solution, remember, alkanes are saturated. The bonds in the alkanes do not show any empty spots for the bromine to react with. Since carbon only has a valency of 4, it can have up to a maximum of 4 bonds. Therefore, it cannot react with bromine. Alkene, on the other hand, can react with bromine because they have empty spots for the bromine to react with. When bromine reacts with alkene, the double bonds break apart, allowing bromine to be joined by the bonds. This forms a new name for the substance as well. So I hope you know something about hydrocarbons now. Thank you for your attention and have a great day!